Good afternoon to everyone. I am Meghnad from the Department of Civil Engineering, Nashopeta Engineering College, Autonomous, Nashopeta. Okay, we will discuss a new subject is strength of materials too. This subject includes in semester second BTech second semester for the civil engineering students. So and also useful for the mechanical students also. So in strength of materials too, there are 5 units. First one, principal stresses and theories of failures. Unit 1, principles of stresses and strains and the theories of failures. Second one, that means second one is springs and torsion of circular shafts. And third one, columns and studs. And fourth one, the next, direct stresses and strains, that means combined direct stresses and combined stresses. And last one is fifth unit. This is unsymmetrical bending and shear center. Then first unit, principal stresses and strains. In this unit, we will able to understand the basic concepts of principal stresses developed in a member when the member is subjected to the different stresses from the different axes. And then second unit, torsion of circular shafts and springs. In this unit, we will be able to assess the stresses of different engineering applications like torsion of circular shafts and springs. Okay, then next third unit is columns and studs. In this unit, we will be able to understand the engineering applications and it's helpful to find the applications of engineering applications like columns and studs. And the fourth unit, this is a very useful and easy unit, direct stresses and bending stresses and combined stresses. In this unit, we will be able to understanding the direct stresses and bending stresses. And the final one, that means that one unsymmetrical bending and shear center. In this unit, we will able to understand the shear center and unsymmetrical bending of different sections like unsymmetrical sections like means I sections and channel sections, Z sections and angle sections. Okay, we find the unsymmetrical bending. We are before we proceed to the strength of materials one, strength of materials two. We already discussed or learned strength of materials one in second BTech first semester. The strength of materials one, including the different concepts. Those concepts are very useful here to gain the knowledge better compared to the strength of materials one. Strength of materials one is very useful and helpful to gain and to proceed further the easy one for strength of materials one. In strength of materials one, we already discussed about the stresses and strains due to the axial loads, and then we will learn also shear force and bending moments and bending stresses and shear stresses and torsions we are here. And then another one is thin cylinders and thick cylinders. Okay, anyway, we will proceed before we learn or we identify or we know about the difference between this analysis and design. Before we identify the analysis and design, how to identify the analysis, the difference between analysis and design. Analysis is based on three major topics: strength, stability, and stiffness. Strength of matrix is the analysis subject. Okay, this analysis is based. That means analysis. That means every member is a to satisfy these three requirements. To analyze the member, we know those three requirements and to identify the strength and stability and stiffness, and then it is a analysis is then furtherly design the member. First we analyze the member, and analyze means analysis is satisfy these three requirements. The and stiffness. So how to identify the strength and stability and stiffness? Like we take the like any one member, like structural member, like beam. Beam is a horizontal member. Beam is a structural member. Beam is a structural member. Suppose we take simply supported beam. Beam is a structural member which carries transverse. Beam is a structural member which carries the transverse load. Transverse load means the load acts perpendicular to the axis. This load acts perpendicular to the axis. It is called transverse load. Okay, load acts perpendicular to the axis of the member. It is called transverse load. So B means B is a structural member which carries transverse load. That means this is a structural member and it carries a transverse load. Like we take a single supported beam. So we take this member and do this identify this member is it has strength, stability and stiffness. These three requirements are satisfied or not. We conclude the final analyze the member. First we will find the strength to identify the strength. How to determine the strength? There is strength. These three requirements was to identify the strength. Strength means the limiting stress. The stress that means allowable stress is controlled by the limiting stress. Okay, strength. How to identify the strength is nothing but the stress is controlled by the limiting value, and furtherly the stress is controlled by the limiting value. How to calculate these stresses? The stresses are two different types. Stresses are two different types. That one is axial stresses and flexural stresses, and third one also, that is the shear stress. Okay, these axial stresses are identified by the force per unit area. So force per unit area. And then flexural stresses. Flexural stresses are defined from the Bernoulli's theorem, like Bernoulli's stresses are this is nothing but also it's called bending stresses. Bending stresses are found from the bending equation, that means My equal to sigma by y E by R. This is the generalized equation for bending stresses. M by E by R. So M means moment of the member. The next I is the second moment of area. Second moment of area. Second moment of area is nothing but moment of inertia. Moment of inertia is represented in SI units, mm power 4 or R meter power 4. Moment is represented in kilonewton meter or R newton mm. Then next sigma. Sigma, it has a different names, that is allowable stress, and limiting stress, permissible stress, and the flexible stress. So it has a different names, and then Y. These are the unit stress. It has Newton per mm square or MPa. It is commonly used units. It is an SI system. And then further the remaining three. So Y. So Y is the distance from the neutral axis to extreme of the fiber. And then E is, we know the that is E is an equantous material property. Generally taken, this is value 2 into 10 power 5 Newton per mm square. And then final R is a radius of curvature, and shear stresses. How to identify the shear stresses? Shear stresses are generally represented in tau. This is a generalized shear stress equation is F A y bar by I B. Okay, tau is shear stress. Shear stress units SI units is Newton per mm square. F is shear force, is in kilonewton or Newton. Then AY bar is the first moment of area. First moment of area. I is already know about this one, moment of inertia. Moment of inertia. And its other name is second moment of area. Then B is the cross-sectional width. Cross-sectional, B is nothing but cross-sectional width at the neutral axis. Cross-sectional width at neutral axis. These are the axial stresses, bending stresses, and final shear stresses. These are three stresses. That means axial, bending is nothing but flexural, and shear. These three stresses are determined, are calculated by using these generalized equations, and these three values are less than or within the limits of limiting value, so that the member it has a good strength, or otherwise it's crossing its limiting value, the member it's not efficient to resistance or ability to, that's not able to strengthen. That means these allowable value less than the limiting value, it has a good strength, or otherwise it's exceed this limiting value, the member should be failed. It is not suitable for the design. Okay. Then next, another requirement is stiffness. Stiffness is controlled by the, stiffness is nothing but deflection. Stiffness is nothing but deflection. Deflection, that means deflection is represented in Y. Y is less than Y max. Y is less than Y max. Thus member, it has a allowable value within the limit. The member, it has a good stiffness or good stability or good strength. That means all these three requirements, strength, stiffness, and stability, we find separately with the different equations, like we already discussed. Stresses are different types of stresses: axial, bending, shear. We use those equations like axial stress, bending stress, shear stresses. We find the stresses, and these stresses are within the limit. It has a good strength. And like same here also stiffness. We find the deflection. Use the different methods like cantilever method and conjugate beam method, moment area method, and double integration method and different Macaulay's method. Those different types of methods used to find the deflections. And the final value it should be within the limits. The member should be stiffness, or otherwise the member exceeds the limiting value, then the member should be failed. Like same, third requirement is stability. Stability is we discussed in columns and direct and bending stresses is most of the cases because the columns are the axial compressive members. Column is nothing but axial compressive member and direct and bending stresses developed in dams and retaining walls of the different conditions. Okay, these are the three requirements of the basic analysis of the member. These three requirements are stiffness, strength, and stability. So these three requirements satisfied, and the member should be analyzed, and then it's furtherly going to decide. Okay, so these are the analysis. So the next class we will discuss the strength of materials too. Of the different, it has strength of materials including contains 5 units. So we already told that one. That one is first unit principal stresses and strains. Second one is torsion of the circular shafts and the springs. And third one is columns and studs. And fourth one is direct stress and bending stresses. And fifth one is symmetrical bending and shear stresses. Okay, next class we will continue